Other forms of pulse modulation commonly used in telecommunications: pulse analog modulation, pulse width modulation, pulse position. Let's have a look at pulse analog modulation. It's fairly easy. As you know, I've drawn in the lines here. They are set. Computer works on a clock frequency. It takes a pulse at a predetermined position in time. Pulse analog modulation just physically says, there's our raw signal, offset it, tell me what the maximum frequency of the pulse is. And then they just mirror the sound wave or the electrical wave just by the amplitude of the pulse. Pulse width modulation, if it's high frequency, send through a wide pulse. As the frequency gets smaller, send through a narrow pulse. As it increases, make it wider. So they modulate the width of the pulse. Louder it is, the wider the pulse, the quieter it is, the smaller the pulse. I'm going to just magnify this in for the last one. The distance or the time between when you send the pulse and that clock changes. So if it's loud, you send a pulse through late. When it's quiet, you send the pulse through on the clock cycle. So that's there, that's there. So that when you demodulate it, you just measure the width of the time between when you should have gotten the pulse of light and when it actually arrives, or pulse of electrical signal and when it arrives, and that difference in time becomes the amplitude. So there, big difference in time, big amplitude. Small difference in time, small amplitude.